Alright, so we're looking at that ACT practice that you did last week. So that's where you are, that's what we're looking at. First problem on that. First problem on that, we had a times 4 minus a minus 5 times a plus 7. Okay, direction said on that one, which the following expression is equivalent. So your first chore on this is you had two things that you needed to distribute. So I'm going to take my a, 4 times a, minus a times a, which I write as a squared. Okay, then here I'm going to take my negative 5. Negative 5 times a, negative 5 times 7. Now let's see if there's any like terms that I can combine. I got a 4a minus a 5a, which is negative 1a. Normally, if we write these in standard form, the highest power comes first, so I'm going to write that negative a squared first, and then I've got minus 35. So that looks like it would have been C. Did you get it right? May remember doing that last week? Pretty simple one. Yeah, I hope you did. That wasn't too much to that. Alright, now on number 2. Number 2, it says, gives us the numbers 0.2, 0.03, and 1/4. And wants us to order those from least to greatest. So the dilemma that you have right now is that they're in different forms. We got the first 2 in decimals, and then we got the last one in a fraction. So I could order them a little bit better if I put them all in one form. So I changed that 1/4 to a decimal. That's the same as 0.25. Okay, so I've got, now I know that 0.2, I've got 0.20. And then when I compare these, 0 is smaller than 5, right? So it's got to be smaller. This one so far is the smallest, but 0.03, it's got a 0 in this spot. So 0 is smaller than 2, so it's got to be the very smallest. So it's got to go first if I'm going from least to greatest. So I would have 0.03, 0.2, and then 1/4, which looks like G. Alrighty. Tell me if you have questions or concerns on any of these. On number 3, I've got x squared plus 4 equals 29. And then if that's true, then what does x squared minus 4 equals, what we're trying to find. So what do I need to do to figure out what x squared minus 4 would equal? Good, I need to solve for x. So over here on this one, what would my first step be in solving for x? Good job, Bailey. So that gets me x squared equals 25. Now I need to undo a squared. How do I undo a squared? Square root. What's the square root of 25? 5. So a 5 is what I'm going to plug in over here. Okay? Actually, I could have stopped at this step because it's x squared, right? 5 squared right there. Minus 4. Should have got 21. Do good on that page. 3 for 3 on that page. I hope that means yes when you don't stop talking. Good. Thank you, Billy. Alright, number 4. I had a graph on that one. And y'all had a little bit of a disadvantage on that because your question was on the Chromebook. So you couldn't really, you had to draw your own if you wanted to look at it close. So it said the vertices of a rectangle are -1, -2, 4, -2, 4, 3, and -1, 3. Okay, so there is the rectangle that would be formed. Almost hit all the lines. I missed that wrong. Alright, the question then goes on to say, when the rectangle's graphed, what percent of the total area of the rectangle lies in quadrant 3? Remember, this is quadrant 1, and they go counterclockwise. Quadrant 2, quadrant 3, quadrant 4. So we're concerned with quadrant 3, so we're concerned with that little part of the rectangle in there. What percentage is that? Now, when somebody first asked me for help on this question, I went and found the area of the whole rectangle. That wasn't real hard to do. I just counted how long this was, how long that was, and then multiplied to get the area. Then I did the same for this new little rectangle down here. Counted how long that was, got the area of it, and then divided to find the percentage, right? Somebody in a later class did it a much easier way. Since you had a nice grid there, they just counted how many squares I had in there, and then saw what percentage these squares made. Way easier on that. So let's see if I can do that. I think my red ones are ones, right? So this will be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's not right. Did I mess up? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Is that right? Is there supposed to be a 25? Okay, so there'd be 25 total squares in there. I've got 2 in this yellow area. So what does 2 out of 25 give me as a percentage? You know, there's 4 quarters in a dollar, so that'd be 8%, wouldn't it? Do 2 divided by 25. Check it out. Got the calculator. Should be 0.08. Do what? 0.08. Yep, so it'll be 8%. Good job. Alrighty. Looks like I did a lot of work on number 5. I got numbers written all over the place. Hope I remember what they all mean. On number 5, it says in 1985, cost of clothing for a certain family was $620. 1985, $620. In 1995, 10 years later, it was $1,000. Assuming the cost increased linearly, that's a hard word to say, what was the cost of the family's clothing in 1991? So we're wanting to find 1991 in there. Alright, so we got to find how much it's going up every year. So I'm going to do that. I'm going to take my 1,000 from 1,000 to 620. How much did that go up? What's 1,000 minus 620? 380, and it did that over 10 years, right? So we could say the cost is going up $38 per year. Okay? I want to know how much it cost in 1991, so I could do that a couple ways. I could go to 1985, where it was 620, and do plus 38, plus 38, plus 38, until I get to where 1991 would be. Or I could figure out what year 1991 would be and plug it in an equation. Either one would work. If 1985 is 0, what would 1991 be? 6. So I'm looking at y equals $38 times 6. Now it's going up $38 every year, but it started at 620, so I would have to add that 620 back to it. And I believe that gets us $848. And you could have got that without writing an equation. You could have just done 620 plus 38, 6, and whatever you get, plus 38, until you got to the year. That would have worked. Alright, number 6 tricked me at first. It's an easy question, and y'all probably did fine, but I had a hard time figuring out if I wanted the squared number or if I wanted the base of it. It took me a while to figure that out. It says the square root of a certain number is approximately 9.2371. That's the square root of the number. A certain number is between what 2 integers? Well, that's between 9 and 10, right? Okay, which is a choice. But this is the square root. So what did they take the square root of to get to that? What's 9 squared? What's 10 squared? So that would be the right answer. Now, not a choice. What's the closest thing there to 100 on that? 81 and 99. It was, what was that, K? K. It made me mad when I was making the form for this because it does FGHJK. So I have to Normally, if it's ABCD, I can just duplicate it however many times. No, I have to go and redo it every time. All right, number 7, got some probability questions. Probability on number 7. A bag has 10 pieces of flavored candy, so we got 10 total in the bag. 4 of them are lemon, 3 are strawberry, and 2 are grape, and 1 is cherry. 1 piece of candy is going to be randomly picked. What's the probability that it is not grape? So I do not want grape, so I could have 4 plus 3 plus 1, right? 7, 8 out of 10, which would be the same as 4/5. So I got a pretty good chance of picking a not grape candy, which is good because I don't like grape candy.
I love grapes.
Grape candy doesn't taste like grapes. Number 8. There's another piece of graph paper here for number 8. Alright, it says when points A and B, and it gives us B, which it says is negative 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. When A and B are graphed on standard XY coordinate plane, the midpoint will be at 1, 2. 1, 1, 2. There's my midpoint. So it's wanting to know where would A be? Well, if this is the midpoint of it, you know it's got to be over here somewhere, right? I mean, making common sense. So first thing I did was I marked out F, G, H, J, and K. Because all of those have a negative X, which means from the origin it would move left first, right? It can't be over here. I mean, midpoint, it would have to be over this way somewhere. The X has to be a positive. Choice K is the only one that has a positive X. Now, could you have figured that out? I mean, I could say, well, I got to go down 1, 2, and over 1, 2, 3, 4. So what if I go down 1, 2, and over 1, 2, 3, 4? Yep, I figured it out. So it wasn't too difficult to do that. All right, number 9. Andrea is managing a company that has 116 customers. Doesn't sound very good, but that is 8 more. We're writing an equation. 8 more than twice a number they had 1 year ago. How many did they have 1 year ago? I don't know. Twice means 2 times. How many did they have 1 year ago? So we're fixing to figure it out. So we're solving that for X. So first thing we would do would be to subtract 8. So that would get me 108 equals 2x, and then divide by 2. So they had 54. Now you could have again gotten that without writing in the equation. You could have just used the choices and went through and doubled them and added 8 and saw which one got you 116. 54 times 2 is 108, plus 8 is 116. You could have done it that way. Good. All right, building a fence on number 10. Says Joseph will have a 200-foot long fence installed around his yard. The A Plus Fence Company charges a $500 fee plus a set amount per foot. So they are going to charge a $500 fee plus.
Call Dixon, please, from high school office.
Doesn't tell us how much per foot, but we know we need 200 feet, right? Because it's so 200 feet times however much they charge per foot. That'd be the A Plus Company's expression. Then it says they've given Joseph an estimate of 2,200, so that would be equal to 2,200. That's the estimate that they've given him. So how much do they charge per foot? So we're solving for X. A lot of Algebra 1 linear stuff on this so far. Subtract your 500. Gets us 200x is equal to 1,700. Divide by 200. That is $8.50 a foot. wonder if that's for labor or materials, because I would think it would cost more. I don't know. I don't know. All right, number 11. For a math homework assignment, Carla found the area and perimeter of a room in her house. She reported that the area of the rectangular living room, which area is length times width, was 180 square feet. And the perimeter, which the perimeter is 2 lengths plus 2 widths, the perimeter was 54 feet. When drawing a sketch of her living room the next day, she realized she'd forgotten to write down the dimensions of the room. So she's only got her answers. She's got to work backwards now. She's already at school. She can't go measure again. She's got to work backwards and figure out what the dimensions are. Okay, so I need two numbers that when I multiply them, I get 180. And then when I add them all together, I get 54. I just went through the choices and saw if they would work. So choice A, it was a 9 by 20 room, so I did 9 times 20, which was 180. But then if I do it here, 2 9s is 18, 2 20s is 40. That does not add to 54. That's 58, right? So 9 and 20 didn't work. Then I did the 10 by 18. 10 times 18 is 180. So I'm good on the area, but if I do the perimeter, 2 10s is 20, 2 18s is 36. I add that, I get 56, not 54. So 10 by 18 didn't work. Then I did the 12 by 15. 12 times 15 again was 180. 2 12s is 24. 2 15s is 30. 24 plus 30, ding, 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 that is 54. So it was the 12 by 15 room. I like those kinds of problems. All right, on the next page, we got the chart there about the candies at Carrie's shop and Tamika's shop that we're using for that whole page, 12, 13, and 14. So, it says, Carrie's Chalk Shop and Tamika's Treat Shop both sell candy in boxes. The table lists the prices, total amount the customer pays of each box of candy sold at the shops. For each shop, there's a linear relationship between the price of the box of candies and the number of candies in the box. These are the only numbers of candies that can be purchased. Number 12. Jeremy has $10 in quarters. $10 in quarters to spend on candy. What is the maximum number of quarters he would have left after paying for a box of 25 candies at Tamika's Treat Shop? So I go find 25 candies. I go over to Tamika's Treat Shop and see that costs $4.25. So he has $10. He's spending $4.25, which means he's going to have $5.75 left. But the question wanted to know how many quarters would that be. So what do I do to figure out how many quarters that is? What's the value of a quarter? So I'm just going to now divide that by 0.25. So he would have 23 quarters left. Why would a kid want all of their change in quarters? I don't know. Maybe it makes them think they got more money. They got a lot of jingle in their pocket.
Do you know the story where like these kids got like $100 bill from their grandparents for Christmas one year, and like their parents like traded them for like $2.5 or something, and they thought they had more money than
Because they had two bills, yeah.
Yeah.
I didn't hear that, but I can believe that.
So, because the kids were like all under the age of 5.
Yeah.
Well, that's so mean.
What would they have done with $100 anyway? That's the best point, Dakota. That's the best point. All right, on 13, it says at Tamika's Treat Shop, what's the average price per candy in a box of 20 to the nearest 1 cent? So I go find a box of 20, and I'm looking at Tamika's.
Avery Black, please from the high school office to check out.
A box of 20 at Tamika's is $3.75. And that's for a box of 20. It's wanting to know per one candy. So I'm just going to divide that by 20. Round, it ended up being like .187 or .1875, but we're rounding this to money. Bless you. So that would round up to 19 cents. All right, 14. Which of the following equations gives a relationship between the price in dollars C and the number of candies in a box of candies at Carrie's Chocolate Shop? So it's wanting us to write an equation for Carrie's place. It's usually we go y equals mx plus b. This time it's going to be cost equals m times the number plus b. All right, so I got to find what the slope of Carrie's place is first off. But I don't think I even did that. I'm looking at the work that I showed now. All I did was I went down through Carrie's place and plugged the numbers into the choices and saw if they worked. That's all I did. Let's go ahead and look at what the slope would be. If I took, on Carrie's place, if I took, that first one was 5 candies, was $1.50, so there's an ordered pair. Then you had 10 candies, was $2.50. So if I'm looking at the slope there, that went, my rise, if I subtract those, is $1 over my run is 5. So that would mean, since my choices are in decimals, 1/5 is the same as 0.2. Right, so my slope would be 0.2. So I'm looking at C equals 0.2 n. It used the n, didn't it? C equals 0.2 n. In the choice, there's only one of them that has that slope right. There's only one of them that has a 0.2. Okay, what I was saying is I plugged them in. Let me write the rest of that equation out. I plugged them in was the other way I knew how to do it. I said, does $1.50 C equal 0.2 times 5 plus 0.5? I went and plugged some in and found the right one that works, right? So you could do that a couple of different ways. All right, we got the last page. Last page. On number 15, which of the following is a solution to the equation x squared minus 36x equals 0? All right, could plug the choices in again. You could do that, plug them choices in, see which one comes out to equal 0, because that's what it says. I thought it was shorter, because remember, that's the dilemma on the ACT for a lot of us, is the time crunch. 60 minutes, 60 questions, 1 minute, 1 problem. So I thought it was shorter just to actually solve this one real quick, because but either way would work. What I see is that both of these have an x, so I'm just factoring an x out to start with. Okay, that's like backwards distributed property, right? Now, x, this means, this x outside, that means that x equals 0. That is one of the solutions, but that's not a choice, so I'm not worried about that one anymore. My other factor, I'll set this equal to 0. X minus 36 equals 0. That is what you were looking for. And that should make sense. If you look at plugging that back in, isn't 36 squared, which is what this says, isn't 36 squared the same as 36 times 36? So it should make sense to you, because you're looking for it to equal 0. Alright, 16 was a good triangular geometry problem. Let's see if I can draw something that looks similar to that real fast. I'll pretend that's what it looks like. Tells us that this supplementary angle is 148 and this one is 140. Alright, it says, what is the measure of DEF? So we're looking for this one there. What's the measure of DEF? Well, do I know this one? Where my mouse is. But I can get it real easy. How can I get it real easy? Good, Bailey. That's a straight line. A straight line's got to add up to 180. So 180 minus 148, that one will be 32. Same thing here. 180 minus 140, that one would be 40. Reason that was helpful is because I know this whole triangle has to add to 180 now I got 72 there. So 180 minus 72 leaves us 108 for that measure up there. I think 17 throughout the day when we did this last week was the one that most people got confused on. Says a company ships notepads in rectangular boxes that each have inside dimensions measuring 9 inches long, 9 inches wide, and 12 inches tall. So they're giving us 3 dimensions. We're packing stuff into a box. You're going to be looking at volume. Volume is length times width times height. So in this case, our box is 9 times 9 times 12. So it can hold 972 cubic inches. Okay. Then it says each notepad is in the shape of a cube with an edge of 3 inches. Well, if a notepad is in the shape of a cube, if it's got one edge of 3 inches and it's a cube means it's like a square. It's all of them are the same. So it would be a 3 by 3 by 3. And it didn't tell you that. That was part that you had to know by the definition of a cube. So that 3 by 3 by 3 means that each of our notepads is going to take up 27 cubic inches. So one notepad takes up 27 cubic inches. How many can I pack into 972? What do I do to figure that out? Just divide. 972 divided by 27. And I think that let me put 36 notepads in a box. Alrighty, on 18. Got f of x equals negative 4x cubed minus 4x squared. It wants us to evaluate for f of negative 4. So all that means is we're plugging a negative 4 in here and solving. So we're going to have negative 4. I'm just bringing that down now. X, negative 4 cubed minus 4 times negative 4 squared. I just plugged a negative 4 in. Okay, negative 4 cubed is 64, negative 64, and then times 4 is 256, and y'all can check my work on that, but that's what I wrote down when I worked it last time. And then here, negative 4 squared is 16. 16 times 4 is negative 64. So that got me 192. All right, number 19 says, which of the following is the solution for the system of equations x plus 2y equals 4 and negative 2x plus y equals 7? Okay, notice how I wrote those? That should bring a memory back to you. I stacked them on top of each other. So remember when we did elimination and got rid of a variable? That's what I'm going to do on this. Okay. My other options would be to plug the choices in, but the choices have to work in both equations. So in order for me to eliminate a variable, they got to have the same number. My x's either need to both be 2's or my y's need to both be 2's. They got to have the same number. When I worked it, I chose to make my x's 2, so I multiplied that whole equation by 2. So that got me 2x plus 4y equals 8. I just distributed a 2 to all of those. Now I didn't do anything to this bottom one. It already had a 2x. So I'm just writing it underneath it. Now 2x plus negative 2x would make that go away. So 2x plus negative 2x, he gone. 4y plus 1y is 5y. 8 plus 7 is 15. So you know y has to be 3. So in an ordered pair, I'm looking for something comma 3. Okay, looking at the choices, there's only one of them. It's got to be A. If there were more than one, and I needed to check, I would take this y equals 3 and I'd plug it in, substitute it in, and solve for y. Okay, I'd say 3 plus 2y equals 4. I just plug the 3. Oh, hold on. I got to do it for x. I'm messing you up. Got to do it for x plus 2 times 3 equals 4. I just plugged it in the y spot. I almost did the wrong variable a second ago. X plus 6 equals 4. Subtract your 6. And that gets you the negative 2 that you needed. Alright, last question. It's the one that the Algebra 2 classes were allowed to miss because they haven't learned about log form yet, but you have. You've learned that in Algebra 2. So you should have been able to try to figure that out. When we did log form, we talked in Algebra 2 about our friend Ben. Remember, that's exponential form, and I can rewrite that into log form. Okay, so the equation they gave on number 20 has log base x of 36 equals 2. So that's an exponential form. It looks like that one up there. My b is there, my n is there, and my e is there, right? So I'm going to take that and I'm going to rewrite it into bin form. So b is x, e is 2, and n is 36. So this says something squared equals 36. Well, what squared equals, how do I undo a squared? What squared equals 36? 6. Alright, there was no really rhyme or reason to those questions when you compare them with what we've been doing in here the first couple of weeks. But it's good math review for us. We're going to take the ACT again. We're going to need to stay fresh on everything. So that's good stuff for us. Monday, we're going on to just some equations, solving equations kind of stuff. So, everybody good on that? Alrighty, thank you much.